Okay. So start with who is the first one? Barinder. What do you mean by AC? Alternating current. So in alternating current, what happen, guys? Magnitude will keep on changing. Magnitude will keep on changing. And when magnitude keep on changing, even direction is also changing. How? If you see in this situation, here you have the positive value, and here you have negative direction, means opposite direction. Correct. So alternating current have both the situation positive as well as negative. One thing. Second, even magnitude amount is changing because in positive negative, in positive negative you have two kind of situation. Even if it is this, if you do this, in this case, what will happen? There is a maximum value, then minimum. So is also like direct is changing positive negative. You know, here magnitude is either positive or negative, but overall it is value remains same. Magnitude remains same, direction is changing. But if you look at the what is happening, magnitude is changing as well as direction is changing. And same thing we wrote, magnitude and direction will change. Uh, what do you mean by
So your voice is
instantaneous current?
breaking, sir.
My voice is breaking.
Yes, sir.
Yes, sir.
Let, let me change the network. So instantaneous current, I asked Jordan. Yes, Jordan, what is instantaneous current? Is my voice okay now?
Yes, I can hear you now.
Okay. So what is instantaneous current and what is the difference between the average and instantaneous?
So average current can is basically current which is passed through a conductor over a period of time, and instantaneous is within that second, within that
Okay.
point.
Sarah, if we compare, because this is given in the current electricity also, and I was supposed to do this, key, if you calculate instantaneous current and average current, how calculation will be different? Sarah, are you there?
Yes, sir.
Yeah, yeah. Tell me. And like if you do calculation for the average current, because this is not just related with the AC, current, electricity, and any other topic, you will simply compare okay, how to do calculation in many chapter, average value and instantaneous value. What is the difference in the calculation? फिर हो रहा है again. हाँ. Yes, Sarah. Answer is when you calculate instantaneous value, you do differentiation. When you do calculate the instantaneous example, instantaneous current, then you do differentiation. In case of, note it down, in case of instantaneous current, let's take this, then you do differentiation of charge. Of charge. One thing. If you calculate average current, then you will do integration of the current. Integration of current. And you will ask, sir, how you are calculating current by using the current? The reason is your current average value, your charge average by time. Okay. And your charge can be equal to I dt into time. Correct. So based on that, you have to do integration. That is the biggest difference when you are solving difficult question, not easy one. In instantaneous, you are using differentiation part, and in case of average current, you are calculate using integration method. But value is different. Example, if you are calculating instantaneous current, you know your I instantaneous is equal to dq by dt. Okay. And if you calculate average value, then you take care of the current node charge. Make sense?
Yes, sir.
So this is extremely important throughout this syllabus, physics syllabus, how to calculate instantaneous value and the average value. So at a given moment, when you calculate current, I is equal to I naught sine omega t. Why we are taking sine, Tuhina?
Sir, I'm not sure.
Because this graph start from zero. It is sine graph. And second thing, you can calculate when you have 90-degree angle, here 180, here 270, here 360. Okay. So if you have different values, so what will you understand? When angle is 90, then your current value is maximum. By mistake, if you take cos at 90-degree, your value should be zero, but it is showing maximum, so it will be wrong. So sine is the right method. Make sense, Tuhina?
Yes, sir.
At 90-degree, it is showing maximum current. But by mistake, if you take cos, at cos 90, it will be zero. Contradict. That's why you should know why. One is
Yes,
graph
sir.
is like this, and second, based on the angle, you can compare. So, Barinder, when will you have maximum current? 90-degree, 270-degree, 90 and 270.
Yes, sir.
And when will you have minimum current, Barinder?
180 and 360
And
and
zero as
0.
well. Yes. Okay. What is the difference between the AC and DC? In DC, you have the same magnitude, same direction, same magnitude. Everything is fixed. But in AC, it is changing. That's why throughout the chapter, you use these two things. Ki instantaneous current at given point and instantaneous EMF. Same method. Instantaneous EMF max and E naught is the maximum value. What Barinder Chandana, whatever we were using so far, like we use in the current electricity, magnetism, which current were you using, AC or DC?
AC.
DC. Why? Because if you compare in your current electricity in battery, you are using same symbol of the DC. Make sense?
Yes, sir.
You are using same symbol of DC. Make sense? None. So whenever you use AC, then you use this wave like form. Okay, you use this wave like form. That is the huge difference because everybody will teach you, okay, this is the AC, this is what we are doing. But I've seen question and then I was so surprised ki, oh, we always say ki this is battery produce current, but we never mention In current electricity, we are talking about only DC, not AC. Tell me, guys, were you aware, like, and cautious about this point? Whatever we did in current electricity, it was DC.
Yes, no, sir.
Huh. Next is the average current of complete AC. If you have one positive cycle, another negative cycle, net will be zero. Average, right? Makes sense. If you gain 1 lakh rupees, you lose 1 lakh rupees. What is the average value? Zero. Correct. So average of full cycle will be zero. Average of the full cycle is zero. That's why to make it better, we take average for the half cycle. Make sense? We take average of the half cycle. Second, in half cycle, how much current is required to pass the charge? So we consider charge in this case in the half life cycle. How much current do you need to pass this charge? It is the half cycle. Any doubt? Any doubt?
No, sir. No, sir.
So remember these 2 points for your NEET exam. See, we are calculating average value for the charge. And second, this is only for half cycle because for full cycle, value will be zero. And when you calculate mean or average, it will be 2I naught by pi. Logically, you will feel ki, sir, it should be 50% of the half cycle. But actually, it is slightly more than that, 63.7% average value, because this change is not regular. This change is not regular. And whatever you will apply to the current, same thing you can use for the EMF example. If you compare here, then instantaneous current, in the same way we were using instantaneous EMF. We were using instantaneous EMF. Okay. So when you calculate the average value of the current, average value, then you will see ki in case of the average value, you can calculate current as well as EMF both equally. Okay. Chandana, tell me, in real life, do we use average value of AC, like current or EMF?
No, sir.
Hmm. We use RMS, and that's what we have, root mean square value of your current or EMF. Remember, in the full chapter, you have both current or EMF. Okay. Even in mean, you had current or EMF. So, if question asks, which current is actually measured by your devices? Answer is root mean square current of AC. Virtual or effective or reading that is measured by the ammeter. So if it is not given, then you will consider only this. And in this case, like, how much current is required to generate heat for a complete cycle? That is the difference. You have to compare between these two. In mean, we were taking half cycle. In root mean square, full. In mean, we were using charge. In root mean square, we are using heat. So Jordan, what are the difference between the root mean square and average value? Jordan, are you there? Kara, are you there?
Yes, sir.
What is the difference between root mean square and average value of AC?
Not sure, sir.
Ruhina?
Sure, it's just the average means it's like the normal average that we take for every
Hmm.
value, but then root means square, like it says, it's the square of the um where it's the we square the values, then we take the average, and then we square root it.
Wow. What are the other difference?
Like average means it's just like the normal. I don't know how to explain it properly, so like
Uh,
yeah, I don't know how to explain it properly, sir.
these are the two, three major difference. In average, we take charge for half cycle and not measured by the ammeter. In root mean square, we take heat for complete cycle and it is measured by the ammeter.
So can you repeat?
If you take average, then it is used for charge.
Can you hear me now, sir?
Yes, Jordan.
Okay, I
For
don't know, my laptop's not working.
okay, for half cycle, mean current or average current for half cycle and not measured by the ammeter. But in root mean square, mummy kiru hage where virtue it is read by the ammeter in consider the heat and use for the complete cycle. Guys, give me just few minutes. It's an emergency.
Yes,
I'll
sir.
be back. Quickly revise what I taught, and I am sending the same PDF in the group. You finish notes. So, Anvita, we were doing AC, alternative current, where magnitude and direction change continuously. Okay. When you calculate at a given moment, what is the value of the current? We said it will be depend upon the maximum value of the current, I naught, and it depend upon the angle. Sarah still have problem. So I value at a given moment. Example here it was taken for the x. What is the value I naught and it depend upon the angle. At 90 degree it will be maximum 180 0 270 again maximum in negative and then 0. In DC it will remain same. Magnitude and direction will be fixed. So if you calculate instantaneous current, same way you can calculate instantaneous EMF. Next, what is the average value of current? Because you have positive cycle, so positive current, negative cycle, negative current. If you calculate total net, it will be zero because positive and negative amount is same. When we calculate the average value of AC, it is the like amount of charges produced by the current in a half cycle. Amount of charges produced by the current in half cycle. And when you calculate the value average after derivation, you get 2 I naught by pi, 63.7% of the maximum current. Same EMF. EMF and everything will be same. Root means square. This is the real current measured by the ammeter. So, Sarah, what is the role of ammeter?
She's not there in the meeting, so she's facing network issues.
Yeah, she's facing network issue. Jordan, what is the role of ammeter?
So it basically it tells us the amount of current which is flowing inside the circuit. It measures
It
the
measure
amount.
current. In the simplest meaning, ammeter measure current. So when we say ammeter measure current, Sandana, which current ammeter is measuring?
Sir, alternative.
Alternative current, root mean square AC.
Yes.
In alternative current, there are two forms, average AC and root mean square. We take root mean square because ammeter cannot measure the average current. Okay. And if current is given, you have to always consider only RMS current. Root means square. It is ulta. First you do square. Example, in this condition, what will happen if you have two current, I1 and I2? If you have two current, I1 and I2, then and if you calculate the value, first you take square, I1 square and I2 square. Then you add them. Then you take under root of them. So first square, then mean, average, and then your under root. Understood, guys? Any doubt? Like because mean, average, and then root. Got it, guys? This is how. What is this? Is the meaning of root mean square. So first you do squaring of all the values, then you take mean of all the values, and then ultimately you add under root. Sara is facing a real network issue. Sara, am I audible?
Yes, sir. Yes.
Okay. So here, Anvita, we take heat, amount of heat produced by the current in one complete cycle. Root means square. What is the amount of heat produced by the current in complete cycle? That current is root mean square. Amount of charge produced in half cycle is average current. Any doubt, Anvita?
No, sir.
Huh. Now we can move because this is the common thing we did. If you calculate root mean square value, then it will be I naught by under root 2, which is 70.7% of the maximum value. Barinder, which one is greater, RMS or average?
Sir, RMS
Yes, RMS is 70.7. What was the value of the average current?
63.
Yes, 63.7. So this is correct. Uh, Anvita, what was the formula of I average?
So formula of
Average current, mean value of AC or average value of AC.
uh, I
2,
by
2 I naught by pi.
yeah.
And here it is I naught by under root 2. So both value are different. You should remember, all of you should remember this. Sarah, if this is the IRMS value, what will be ERMS value? Sarah, what
Uh,
will be ERMS value? E naught by under root 2. Same like current. Understood? Sarah?
Yes, sir.
Hmm. So if calculate this value. Jordan, what is this 5 in this case?
So the 5 is basically I naught.
Yes. And what is this 314, Chandana?
Sir, omega.
Very good. Omega. You have to calculate IRMS. Barinder, what will be the formula for IRMS?
Sir, 2 I note by
No. I naught by under root 2. Correct? I naught by under root 2. So what is your I naught value, Anvita? 5.
Sir,
This is under root 2. Then was it difficult? Anybody have doubt? How we got this answer? Anybody have doubt, guys?
No, sir.
If not, then solve this question. Calculate instantaneous voltage of AC supply of this. Hello. Okay, no problem. Joy. Yeah. So, Sarah, what should be the formula in this case? Instantaneous voltage.
I note.
E naught sin omega t.
Yes, sir.
In this case, what is your, if nothing is given, what value is provided to us? E RMS. Hello. अनरमबिर ना मैं और एक बार सामान लेने गया था काम में ही किसके हलवाई के पीछे ना भाई उसके रह रहे हैं आज दे आवांगे तेरे रिश्तेदार जा लिए ठीक है आधा फिर 1 घंटा लग जा भाई मैंने क्लास लेने दे रहा क्योंकि मैं बीच में ब्रेक लेने गया था लेकिन मैं मनोज और का जाया तो मैं बोले कि सामने आ जी क्योंकि मैं बाहर जाऊंगा निर्माण रावण थे बोले सामने बैठ के बात करा हाँ हाँ अकेला गया था न्यू कहने खातर भाई जो मैं हरकतें हुई है नहीं तो मेरे जो मैंने बताया कि देता है हाँ नहीं ना उन तक को नहीं बताया गया तो मैं बस नहीं कह गया मैं कि कई बार ऐसी चीजें हो जाए कि मैं अपनी जो शब्द है उनकी वैल्यू करूँ तो उस हिसाब से मैं अपने बात करूँ बोले ठीक है तो सामना कर लेंगे मैं जब इमरजेंसी में बाहर निकला था हाँ हम्म भाई इसे हम दे बेटा हम खुद नहीं ले लेंगे हाँ, हम्म बिल्कुल हाँ बस बात कर मैं तेरे से बताऊंगा बैठ के बात ही मैं बस क्लास खत्म कर देते तेरा फोन कर ठीक हाँ तो ही ना how much you covered from this PDF while you were reading
Sir,
how much you have covered from this PDF while you were reading
so
did you
one
finish this
second, I'll
part
tell. 1 second.
everybody finish this question second question
Sir, till AC through capacitor.
So before that, you revised everything.
Yes, sir.
Okay. So what is the answer of this question second?
Sir, I'll solve and I'll tell you 1 second.
Sure. Anybody got answer? In this case,
So,
yes.
so omega value is 100 pi, no?
Omega value is
100 pi.
100 pi,
Omega is
correct?
equal to 2 pi by t, and then that
Correct.
becomes a 2 pi frequency. Frequency we have, multiply it, and then we just
Correct.
get it.
Omega value will be equal to 2 pi frequency. 2 pi frequency value is 50 is equal to 100 pi. Okay. So you have omega value t. We don't need to apply. Yeah. E RMS is equal to E naught by under root 2. If you want to calculate E naught, it will be under root 2 time of 220 volt. Then you have E naught value, you have omega value. You can apply all the rule and place here E naught value, place here omega value. Done. Make sense, guys? Hmm. We did same thing.
2 minutes.
Anybody have doubt? So what are the formulas you are applying? If VRMS or ERMS is maximum value by under root 2, and second, omega is equal to 2 pi into frequency or 2 pi by p. Okay. So we applied the same equation and got this answer. Anybody have doubt? Let me know.
No.
Okay. So then AC through resistor. It means when you supply current, then when you face resistance, it will lead to the some kind of voltage, because we know voltage is equal to I into R. Correct? Voltage into I into R, and voltage is also equal to E naught sine omega t, according to the instantaneous formula. E is equal to E naught sine omega t. What will be your current value? Your voltage by resistance. Voltage value is this. This is resistance. And we prove the same formula. I is equal to I naught by this. In this case, what will happen? Your current and EMF direction is exactly same. Your current and EMF direction is exactly same. Anvita, does current and EMF have different direction? Anvita, are you there? She is not. Anvita, Barinder, Chandana, Jordan, Sara. Okay, Barinder, are you there?
Yes, sir.
So can you say in both the graph, if you compare I naught graph and E naught graph, both start from the zero, both have same point
Yes.
at 180-degree angle and 360-degree angle or any angle. Angle is exactly same. We are not talking about the amount. Which amount is more, uh, Barinder? Out of E naught and I naught, which value is more?
E naught.
Why? Why?
More angle.
No, because you know E naught is equal to I naught into R. So you will multiply with R now. There is some resistance. And when you multiply with R will have some value and overall E naught value will be high. Make sense?
Yes, sir.
Angle between them is zero, that is phi. Phi means angle between the current and EMF is exactly same. Anybody have doubt, guys, in this resistor?
No, sir.
When current pass through the resistor, current and EMF will have exactly same direction. Though EMF value will be slightly higher because it is multiplied with R. Okay. Second is through inductor. When you calculate E is equal to E naught sin omega t, same formula. That's why you will feel if you know the basic, every time we are using same formula only. Tuhina, how we got this E is equal to minus di by dt?
So where, sir?
In AC through inductor, alternative current through inductor, E is equal to E naught sin omega t.
Yes, didn't we learn this in EMI?
Exactly. So what exactly we learn in EMI?
Sir, this formula, like, um,
How to derive this? Yes, you are right. In EMI we did this. That's why I'm asking revision.
I'm not sure how to derive it, sir.
Okay. Tara,
So self-inductance.
self-inductance. Yes. So what was the formula of self-inductance? N phi is equal directly proportional to the current. And if you take proportionality constant, it was Li. Any doubt, guys? Tuhina,
Sir,
first
can you
formula was
repeat?
this. Your phi magnetic flux directly depend upon the current, more flux.
Yes, sir.
So N phi directly depend upon the current and it will be equal to N phi is equal to Li.
Okay.
Second, Sarah, do we know E is equal to minus N d phi by dt?
Yes, sir.
So instead of N phi, we can write Li. L is constant. You can write the same formula in this formula N d N phi by dt. Make sense?
Yes, sir.
So instead of N phi, we are writing Li. L is constant, so will come out. Current is changing. That's why this. So both of you, Sarah and Tuhina, was it difficult to derive?
No, sir.
But you should know in physics how to derive the different formula, not for any theory purpose, but to correlate even if you don't know.
Yes, sir.
If we are putting the value here, what will happen? I is equal to I naught sine omega t minus pi by 2. Can you say in this situation, our current is 90 degree behind the voltage? Minus, because you have this thing extra. Otherwise, formula is remain same. I is usually I naught sine omega t. Here we have minus pi by 2 as well. It means our current is behind. Current is behind. Just remember, current is behind in inductor. In inductor, current is behind. In inductor, current is behind. It means in capacitor, what will happen, Jordan?
It will be ahead.
Ahead.
It will be
So,
leading.
so you know inductor and capacitor is ulta, opposite to each other. You just need to focus ki, okay, in case of inductor, current is behind. Chandana, can we say if current is 90 degree behind in inductor, is it correct to say ki voltage will lead 90 degree compared to the current? Same meaning? Yes or no?
Yes, sir.
And Varinder, if we say ki in case of capacitor, it is opposite and current is leading 90 degree, then voltage will lag 90 degree in capacitor. Varinder.
Yes, sir.
Huh. So what happen in case of inductor? Our voltage lead by 90 degree, or you can say current 90 degree behind. Correct? Current 90 degree behind, or voltage lead by 90 degree. If voltage lead by 90 degree, current will be behind 90 degree. Same meaning. So if you go through everything, it will be confusing. Just focus on one thing. It's your choice. If you want to say कि in case of inductor, you know that L value will be responsible for the change in the voltage or current. And here, if you write voltage is leading by 90, then automatically current will lag behind by 90-degree angle. And in case of capacitor, it will be exactly opposite capacitor. So your voltage will lag by 90 degree and your current will lead by 90 degree. Can you say, guys, if you focus only on one thing, it's your choice, whatever you want to choose. Everything else you can say will be ulta. Choice is yours. If you want to uh, keep this, okay, I will keep current is 90 degree behind in inductor. Remaining thing will be opposite term. But focus on one point and all are correlated. All are correlated. Just focus on one point. And that's the biggest issue student face. What they try to do, they try to memorize all four. And then they mix up the concept. And in the end, ki, sir, I was aware about this, but I made mistake. At the same time, I was confused. Ki, which one should be the answer? Tell me, guys, every single person, does it happen with you in such kind of topic? Anvita,
Yes, sir.
Barinder,
Yes, sir.
बरिंदर तुम ये क्वेश्चन पूछती हो यस सर या बता रही हो
सर आपको क्या लगता है? मैं तो आंसर दिया था।
मुझ अच्छा फिर ठीक है नहीं मुझे कई बार ऐसा लगता है कि जो टोन है ना उस टोन से कई बार ऐसा लगता है कि सर क्या पूछ रहे थे आप यस सर एक वो भी तो टोन होती है चंदना डू यू फेस confusion not difficulty but confusion ki what could be this 90 degree ahead 90 degree
Yes.
behind
Yes, sir, sometimes.
sometime Jordan
Yes, sir.
Sara
Yes, sir.
Suhina
Yes, sir.
huh. So that's why intentionally I am giving time. Why? I told you ki we could finish syllabus on time, but more than that, it's important to give you the clarity where you might make mistake. Where you might make mistake. So whether you take the first red color, VL is above, or second red color, VL is still above, both are correct. And angle is 90 degree in both the situations. See, this yellow is 90, this is still 90. Both are same thing. It's your choice how you want to represent it. Now look at this. You can see current is behind the voltage. Why? Because you can see your voltage start from the zero, but current start from the negative. Understood? Voltage start from the zero and current start from the 90 degree behind. Now it makes sense according to the diagram. In phasor diagram, such kind of diagram where you use this straight line, this is known as phasor diagram. In phasor diagram, what happened? Angle difference is 90 degree. Which one is behind? Current is behind. Which one is leading? EMF is leading. voltage is leading. Make sense? It's your choice how you want to show this. Anybody have doubt? Let me know. Current is 90 degree behind the voltage. Anybody have doubt, guys?
No, sir.
If not, then we can move to the inductive reactance. Inductive reactance is almost like resistance in the inductor. It is almost like resistance in the inductor. If you calculate resistance in the inductor, how will you calculate resistance in the inductor? What is the inductance and omega? Omega is equal to 2 pi nu or 2 pi f frequency. This is the thing. Got it? In case of DC, you know current is not changing. It is same. So frequency is 0. If frequency is 0, your resistance will be 0. If resistance is 0, maximum current. Any doubt, guys? In DC, because current is fixed, current is not changing, frequency will be 0. Frequency 0 means your XL resistance in the inductor will be 0 and then current will be maximum. Okay. If you use AC source and use high frequency, condition, term and condition apply, use high frequency. High frequency means your XL value will be high. XL value high means overall resistance is more. Resistance more, current will be less. I low. I low means current will be less. Any doubt? So, in case of inductor, because resistance is 0, it will allow DC, but it will block AC at high frequency because resistance is too much. Anybody have doubt? Should I explain this again or you understood everything?
Sir, can you explain it again?
Yeah.
I'm finding it a little bit hard to understand this chapter.
It's okay. I will explain everything. So, we are doing inductor. In case of inductor, if you calculate the current, how to calculate current overall value? I naught remains same, sine remains same, omega t remains same, but in minus it will be pi by 2. This is the important equation. As in the equation you can see, okay, there is a difference of 90 degree angle. Sarah, can you hear me?
Yes, sir.
Okay. So, in case of inductor, if you want to calculate current, you can see your angle is 90 degree behind. How do I know? Because minus pi by 2. If you write plus pi by 2, it
It's
means
leading
you
by
are
90 degrees.
exactly. If you write this equation, I is equal to I know sine omega t. This is the common value. But now, if you add pi by 2 means 90 degree extra. This is leading by 90 degree. Such thing happen in case of capacitor. Okay. So as from this, you know current lag means behind 90 degree. We can also say ki voltage lead by 90 degree. In this case, you can say current lead by 90 degree, then voltage lag by 90 degree. Any doubt?
No doubt, sir.
If you agree with this, next point is ha, uh, inductive reactance. Inductive reactance means resistance in the inductor. X means resistance. L means in inductor. What is the formula of this XL? L omega, inductance and frequency.
Yes, sir.
You know your angular velocity will be equal to 2 pi into frequency. Any doubt to Hina till here?
No doubt till here, sir.
So this nu is your frequency. Now you want to understand what happened in case of AC and DC. In case of DC, you know your graph is like straight line. In case of current, this is time. With the time, your current is fixed. With time, current is fixed. If current is fixed, there is no role of frequency. Frequency happen when you have waves. Frequency happen when you have wave.
Yes, sir.
Example this here you have wave value is increasing, decreasing, increasing, decreasing. Okay. So in this case you will have some frequency, but here frequency will be zero. Frequency will be zero. Okay. If in DC your frequency is zero, then your formula 2 pi omega will be also zero because your frequency is zero. It means your XL value L omega will also be zero because through this your omega is zero.
Yes, sir.
If this is the situation, your resistance of inductor is zero, can you say your current will be maximum?
So can you repeat?
Your if your resistance is zero, then your current will be maximum.
Yes, sir.
It means if you are using inductor and you are considering DC direct current, then you will have maximum current and minimum resistance, which is good thing, right? Any doubt?
No doubt, sir. Understand.
But if you take AC, in AC frequency could be different type. We don't know what will be the final value, but it is considering second factor also high frequency. High frequency means your new value will be high. If your new value is high, your omega 2 pi nu will be also high because nu is high. Then your XL value, which is equal to L omega, will also be high because your omega is high. In it means your resistance is maximum in this case. Correct? If resistance is maximum, can we say current will be minimum?
Yes, sir.
So can we say in case of inductor, if you are using AC only with high frequency, very high frequency, then your resistance will be too much. If resistance is too much, it will not allow current to pass through it.
So can you repeat that?
If resistance is too much,
Yes, sir.
so passage of current is not possible, right?
Yes, sir.
That's what we are saying here. In case of inductor, if you are using AC with very high frequency, then your resistance is too much that current will not pass.
Yes, sir.
Understood?
Yes, sir. Understood.
Everybody understood, guys?
Yes, sir.
Yes, sir.
Hmm. So don't hesitate. If you feel you are not really comfortable with the topic or you did not understand, just tell me straightforward, sir. Can you please explain once more? Okay? There is nothing wrong. We can take more time. Time is not issue with us because we have almost finished syllabus. Just in physics 2 3 chapter are left. But if you don't understand, it will remain same. Our inductor is done. We have to do AC through capacitor. This part is also done. I is equal to I naught sine omega t plus pi by 2. It means your current is leading now. Anvita, what will happen to the voltage in this case? If current is leading, I current lead by 90 degree, what will happen to the voltage or EMF? Is it leading or lagging?
Does it lag?
Yes, it lag by 90 degree. Lag means behind. You can see here, current is leading is 90 degree ahead of your voltage. Understood? Anybody have doubt?
No, sir.
And see, same thing you can see, your black color is EMF or voltage, and your this violet color is current. Now current is 90 degree. When your EMF was zero, I will consider when your EMF was zero, then your current was maximum. Got it? So 90 degree. Leading. Current is leading now. Correct? Any doubt, guys?
No, sir.
No, sir.
And same diagram it is written in the this red color. Current is 90 degree leading compared to voltage. Capacitive reactance you take in denominator. In inductor you are using in numerator, and capacitor you are using in denominator. Okay. C remains same. Omega is equal to 2 pi milli. Okay. So here, if you consider DC, in DC you know frequency 0. If frequency 0, then your angular velocity omega will 0. And if omega is 0, your axis will be infinite. Maximum resistance. Maximum resistance means minimum current. And if you take AC at high frequency, then omega high means your uh, XC will be low. And if XC is low, current will be maximum. Make sense? Exactly opposite to the inductor. Why? Because in inductor, your formula was, where should I write? Like, I can't zoom out this PDF. That is the biggest problem. So, in case of inductor, your XL was L omega. Omega was directly proportional, correct? But in XC, your omega is inversely proportional. That is the biggest difference. Understood, guys? That's why if your omega increase, then your XC will decrease. If your omega decrease, example in DC, because frequency 0, omega 0, XC infinite. Make sense?
Yes, sir.
Ask me in doubt about the capacitive reactance. Capacitor block DC act as open circuit. Open circuit means it does not allow current. It does not allow current, but it pass AC at high frequency. Anybody feeling it is too much, or like it's very easy to understand? Got it, guys?
Yes, sir.
Anybody is facing issue and feeling that it is too much?
So I'm not feeling it's too much. I'm just still not confident with it. I think I need to do question.
Okay.
Even I'm like not confident with this chapter.
Neutral
The
feelings, sir.
neutral feeling. Okay, in that case, I will explain the same like how I did for the, because three people showed me. So in case of capacitor, if we are revising, then you know your I is equal to I naught sine omega t plus pi by 2. We already said there is a difference between inductor and capacitor. In this case, we can say current lead by 90 degree or pi by 2. Any doubt? If you see the diagram, your current will lead, like this graph will be current will be maximum and EMF will be 0 at this case. Okay. If you see the phasor diagram, if this is your EMF, then current will be 90 degree ahead. Current will be 90 degree ahead. Next, your capacitive reactance XC is equal to 1 by C omega. And it is different from your XL, which was L omega. So XP is inversely proportional to 1 by omega, but XL directly proportional to omega. Correct? In case of XL, if you compare, if this is voltage, then this will be the current, 90 degree. Any doubt, guys? As of now? हाँ बुआ. So, guys, in this case, if you know, in case of DC, frequency is not changing, your omega will be 0. If frequency is not changing, omega is 0. And you know omega is equal to 2 pi nu. So if this nu is 0, frequency is 0, then omega will be 0. If omega is 0, you know xc is equal to 1 by this. This c omega will be 0, and you know anything 1 by 0 will be infinite. You know here resistance is maximum. So current will be minimum. Okay. Current will be minimum because your resistance is maximum. So this is not good thing because it is not allowing current at all. So we will say कि capacitor will block DC. Why it is blocking DC? Because too much resistance. Any doubt? Jordan, Anvita, and Tuhina.
No, sir.
No, sir, no doubt.
No, sir.
If you take AC at high frequency, omega is high, then your new if nu is high, then omega 2 pi nu will also be high. And you know xc is equal to 1 by omega. So if your omega is high, then your xc will be low overall. Resistance will be less. And if resistance less, current will be maximum. This is good thing. So can we say capacitor at high frequency, at high frequency, it will allow AC. Why AC it is allowing? Because current can pass. Allow means is current passing or not? If it is block means it block current. If it is allowing, it is allowing current. Look easier. Anybody have doubt? Anybody have doubt, guys?
Sir,
All
no
right.
doubt, but I'm
No,
still not
sir.
feeling confident. I think I need to solve question, that's all.
Yes, we need to solve question. But you are feeling better, Sarah,
Yes, sir.
Chandana,
Yes, sir.
Barinder, Barinder, Barinder. So next, Jordan, any doubt?
No, sir.
Anvita?
No, sir.
So these topic are extremely important because if you understand this topic, your LCR is just piece of cake. Because LCR is all about these three topic together. These three topic together, as you can see in the diagram. Do you want to take break or should I continue?
So continue, I guess.
Okay. Everybody's okay if I continue?
Yes, sir.
Yes, sir.
Okay, just give me 1 minute. I'll be back. My mic is on. Guys, so if you see LCR circuit in series, we have only series in our syllabus. All three, inductor, capacitor, and resistance are present in parallel. Okay. You have to consider only one and consider current in this direction. Current in this direction only. Current. Whether it is inductor current or capacitor current or resistor. You know, in case of inductor, your voltage lead by 90 degree. Just remember this thing. In inductor, your voltage lead by 90 degree. Then capacitor, it will be ulta. Current voltage will be 90 degree behind. And in case of resistor, it is parallel. It will be parallel V R. Any doubt, guys? जाकर ले आइए दोबारा फिर. Any doubt, guys?
No, sir.
Huh. So you know, in case of series, current is constant. In case of series, current is constant. In parallel, voltage is constant, right? Right. Same way, if you are calculating voltage in the inductor, current into resistance in inductor. Okay. Same in capacitor, current multiply by the resistance in the capacitor. Correct. Then last, in case of resistor, resistance as simple. Anybody have doubt? Anybody have doubt? So voltage in three situation: LCR, inductor, capacitor, and resistor. Because your inductor voltage is up and capacitor voltage is down, both are opposite to each other. If you want to calculate net value, then you can say one value is positive, another is negative. Make sense, guys? Anybody have doubt?
No, sir.
So this is the voltage in the upper part, as you can see in the diagram also. VL minus VC. Perpendicular to this, we have VR. By using these two, can you calculate your resultant voltage? Your resultant voltage. And your resultant voltage, can we say net voltage will be VR square plus VL minus VR whole square under root. Anybody have doubt? Net voltage will be this. Yes or no, guys? Say yes.
Yes.
Look easy as of now.
Yes, sir.
Same way, you can consider the total resistance of the full system. And total resistance of the full system is known as Z, impedance. Total resistance of the full circuit is known as impedance. And because current is common factor, overall current in the series remains same. So current will be cancelled out. If current is cancelled out, you can take same way resistance also. Tell me, is it difficult to understand? Guys, is it difficult to understand?
No, sir.
No, sir.
Done. So, and you will have question in this way only. E naught is voltage. Voltage will be current multiplied by Z. You can write them. What is tan phi value? For this, you need to understand what is phi. Phi is the angle between the resultant and the x-axis. Resultant and x-axis. So tan phi will be what is your perpendicular and horizontal part, correct? What is the tan phi? Perpendicular by base. What is perpendicular? XL minus XC. What is base? R. Look at the diagram also. Whenever you are calculating tan phi or cos phi, look at the diagram. Tan phi perpendicular by base. Perpendicular is XL minus XC. Base R. Same way you can consider voltage also. Look easy, guys.
Yes, sir.
Cos phi. If you want to calculate, Jordan, what is cos phi formula? Base by hypotenuse.
Hypotenuse.
What is your base in the diagram? R.
Base is R.
And what is hypotenuse? Z.
Z.
Done. Or if you take in the form of voltage, it will be VR by V. V is total. VR is only for the resistor. Correct? Correct. If XL and XC value is equal, then XL minus XC will be 0. Then phi will be 0. Because then phi will be overall 0. Correct? If XL is greater than XC, then phi will be positive. Then inductance will dominate because XL is more. Inductance dominate. If XC is more, then capacitor dominate. Ask your doubt. Think about it, observe carefully, and ask your question. Then, guys, if XL or VL is more, then inductance is dominating. If XC or VC dominate, then it will be more. Done?
Yes.
Yes or no?
So what time does class end? No,
I
because like my
wanted to
uncle
finish the
asked for lunch
resonance,
and
small
yeah,
topic,
and
quality
plus I've
factor, average power. I think maximum half an hour it will take, but I will take one more session. It is 1:53. I will take next class at 3 o'clock.
so because I have to pack and go back to the hostel tonight, like today evening, and then tomorrow test, and then have to come back again.
So can we
Okay,
take at 3:30
3:30. Yeah, fine.
or
Well,
4, whatever is fine with
3:30 I'll take, but I will solve some question now.
Yes.
Anybody have doubt till now? Because if you feel, sir, it look boring when we read the notes, then I can write same what we did in the chemistry. It's your choice.
So right now you're completing the like topics or like you're just doing questions?
I am finishing. No, 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 not only topic. We have to solve question.
Okay.
Yeah. So if you are okay with this, let's see your question. How was question in 2025? This is chemistry. Go back to the physics, chapter wise physics, then AC. Huh? Why you have like this? If it is like this, it's good. Topic wise, AC circuit and power. LCR circuit, very good. Solve this question, guys. Open. Inductor have inductance L, capacitor capacitance C, and resistor R connected in the series. Doesn't matter. Potential difference across the L, C, and R is 40 in resistor, then 10 and 40. What will be the resultant voltage? VR square plus VL minus VC whole R square under root. Correct. Amplitude of the current, maximum value of the current will be equal to 10 raised under root 2. You have to calculate impedance Z value. So what will be your Z value? Z value is like resistance, and your resistance V is equal to IZ. Z will be equal to V by I. You can calculate voltage by this method. You need to calculate current, and you will be done. Calculate and tell me your answer. Make it fast. 40 minus 130. 40 square plus 30 square under root. So it will be 50 volt. If maximum current is 10 raised to 2, what will be the RMS current? Because we consider RMS only I naught by under root 2. So what will be your IRMS? 10 under root 2 by root 2, 10, 50 by 10. Everybody understood what I did?
Yes, sir.
If not, then I will explain through the proper explanation. See, in this question number 1, you have your VR value 40 volt, VL value 40 volt, and VC value 10 volt. Okay. Your maximum current is 10 under root 2 ampere. You have to calculate Z impedance. For your Z, formula is V by I. Both RMS. If nothing is given, you have to always consider RMS. How to calculate V? Formula is V R square plus VL minus VC square. Second, if you consider current method from the IRMS is equal to under root 2. Okay, you have to use two methods. If you use first formula, then V is equal to, what is VR value? VR value is 40 square plus what is VL value? 40 minus 10 whole square. It will be 40 square plus 30 square under root. And you know 40 and 30 value will be equal to 50. How? Because 40 is 1600, this is 900, it will be 2500, and 25 under root will be 50. Anybody have doubt how to calculate V? And if you want to calculate I value, I naught value given is 10 under root 2 by root 2, 10 ampere. Anybody have question in these two points? Using this formula here and getting this, and using this formula and getting voltage 50. And now this is direct. Z is equal to V by I. V is 50 and I is 10. 5 ohm. Tell me guys, was it really difficult?
No, sir.
No, sir.
No, sir.
If it was not difficult, then you can solve one more question.
Sir, can I go for lunch and come back?
Yeah, sure. I will do this last question, then we'll have break
Okay, sir.
till 3:30. I will give you enough time to solve this. This is the last question. You have C value. This is VRMS 200 volt. RMS value of current you have to calculate. Calculate it. Calculate it. I am here only. Calculate it. Guys, tell me what is your answer.
So I think it may be option B or C. I'm still solving.
Reason. How explanation?
No, I'm still solving 1 minute, sir.
देख लियो. देख लियो. It is 250 by pi. This is
I'm getting B.
B. IRMS will be VRMS 200 divided by 250 into pi. Slightly less than 3. Yes. All of you got 2.5, guys?
Yes, sir.
Yes, sir.
Done. Yes, it is B. So what you need to do? Final formula is you need to calculate IRMS. It will be VRMS divided by resistance. And in this case, you have only one resistance. That resistance is capacitive reactance. That resistance is capacitive reactance. So RMS value is already given, 200 divided by this. You have to apply formula and calculate the value of XC using XC is equal to 1 by C omega. Make sense, guys? All of you get the same way.
Yes, sir.
Then let's do one more question. Last. Though I wanted to do another last. First, observe these questions. Variation of EMF with the time for 4 types of generators are shown in the which of the among can be AC. All three are correct. Why? Because in case of alternative value, what is the meaning? It will increase, decrease, zero, increase, decrease. Here, see, this is negative, this is positive, this is negative. Positive, negative, positive, negative. Correct? So all are possible. Even if you see here, positive, negative, all are possible. If you see most, yeah, all are possible. But if you see the most accurate among the AC is like A, most accurate is A, but all are correct, right? Why? हीरू बस 1 मिनट, बस मैं खत्म करूं 1 मिनट, 1 मिनट, बस 1 मिनट, 1 मिनट. Any doubt, guys? Value should increase, decrease. Value should be positive and negative. In all the graph, you have positive, negative, increase, decrease. Any doubt? All are correct. Understood? Yes or no, guys?
Yes, sir.
Yes,
Yes.
Yes. I think you are tired. We'll take break till 3:30. You will solve how many questions? 5 questions, because 2:30 maximum you will work. Then 1 hour break, proper break. 3:30 I will finish this AC chapter completely.
Yes, sir.
Okay. 3:30 next class. See you guys. Till then, take break and send me notes in group right now.
Yes, sir.
Okay. Bye.
Thank you, sir.
thank you, sir.
Okay. Okay.